Now, what you need to know is there are few ways of doing this. So try to understand the question first. The thing now is you have a circle of radius r. So this is a constant. Just know that this is a constant, okay? You need to know which are the constant and which are not, because especially when you're using calculus, you know there's a constant, right? So we're just going to try and understand how this works. The circle. Okay, so let's look at the circle here. Okay, just circle. This is two-dimensional, thank goodness. Then if this isosceles triangle, isosceles meaning not equilateral, right? So you start off with like that in the middle, so it's isosceles, and it's like that. Okay, just slowly. Now you realize that I always regurgitate the same thing one, so this is a center O. Of course, in exam, they will give you more clues lah. But even if they come out like that, you should know how to solve it. Okay, so this is 0. Great. So what to do next? I said it before. I always regurgitate the same thing. As far as circle is concerned, it's always very good if you can draw out the radius out. Okay, and even better if you could draw out the radius which touch the circumference, right? Which touch the surface, right? So here we have r here, which is a constant. R is a constant, and r. Now this is isosceles triangle, so you will assume that this, you will know that this and this triangle here are actually congruent, right? Then this bottom one is another triangle which you will need to find. Okay, now, so where is the what do you call it? The question now is where is the variable? Okay, you should pick a variable now. So there are a few ways of doing this. I think one variable which I could think of is the angle. That will be the one which is quite obvious to me. Okay, so meaning if this could change, then it will be good lah. You can use this as an angle or use this as an angle. It doesn't matter. You will still get the same thing, right? So either one would do. Maybe you want to use this. Yeah, I can use the one below. The one below there. You could also use maybe the variable. I'm not sure whether this x here would make sense. Yeah, this one will make sense. This could also be a variable, so you can just use the x here. So essentially, what you want to find is find a variable. So meaning you just change something. Okay, so I'm gonna use two methods. The first one, obviously, I'm gonna use the angle here. This angle here. So just vary this. So as theta vary go up and down, you can see that actually the angle of the area of this triangle changes. So that's why is it. So method 1, I'm going to use trigo. Okay, this part here, I'm going to just let this angle be theta. So then let me label ABC here. Okay, with the diagram here. So let angle ABC, AOC be theta. Okay, so it's pretty okay lah. Once you're done already, you can actually find the area. So this one here, this one will be this angle here. Hence this one AOB will be 2 pi minus theta divided by 2, right? That's pretty okay. So area of triangle ABC would then be half AB sine C. So it's OA OC sine AOC plus half. Okay, I can just use one triangle here. I'm going to use one triangle and multiply by 2 because these two will be congruent, right? Because these two is definitely congruent. OA times OB, AOB. Then I'm just going to multiply with this area by 2. So this is the area in question that I need to find. Then OA, this is half r square sine AOC, which is theta, plus half r square sine AOB, which is pi minus half theta, times 2. So this is A. Okay. Question. Essentially, once done, r is a constant, theta is the variable, so dA d theta will just be half r square cosine theta plus r square cosine pi minus half of the theta, cosine sine, yeah. Then this will be minus half. Okay, remember that you need to do this, okay? Meaning you just need to find this. Now, did you want the exact? I think the answer is given exact, so I will just find exact. If they don't know what exact, you can actually just use GC, calculate it out, okay? You don't need to like do it. So this case here, I'm just gonna bring out the r square out. So this will be cosine theta minus cosine pi minus half theta. Okay, so this case here, second quadrant, that will be a negative, but okay, if you're not confident with that, well, you can use cos A, cos B, plus sine pi, sine. Okay, so I'm just using this cos A minus B. It's cos A. So cos pi is negative, cos pi. This is 0, so you will get negative. So this is half r square. Then this is cosine negative cosine pi. So this is cosine theta plus cos. There you go. Okay. Yep. That's how we do it. I'm not sure if you want to show is maximum, we can use second derivative later, but anyway, I'm gonna just let add stationary value dA d theta is 0. So this case here, what I'll get is actually just cosine theta plus cosine half theta is 0. So how do you solve this? You can actually just, now this is secondary school stuff, so I'm not going to explain too much, but you always look at the angle. If the angle is different, you change to the same one. So this one you can half the angle. I think what we're going to do is just use cosine 2a is equals to 2 cosine square a minus 1. Another cosine theta is equals to 2 cosine square theta over 2 minus 1. When a is theta over 2, so we can just use this, and this will give us 2 cosine square theta over 2 minus 1 plus cosine half theta equals 0. 2 cosine square theta over 2 plus cosine. Okay, this one I think okay lah. This is quadratic expression here, so I'm not gonna explain too much here. I'm gonna use GC calculator. Then this will be polynomial 2, 1, negative 1. This cos theta is minus 1 or half. Okay, cos minus half. Cos inverse half would be pi lah. So we do not want pi, so reject. Just cos inverse negative 1, 180 pi, and then cos half 60. Okay, obviously we do not want this one because 2 pi doesn't make sense. Reject. theta is between 0 and 2 pi, I guess. Okay, it cannot be, so this one will be theta equals to 2/3 pi. There you go. So you can use second derivative test to show its maximum. You can just use that. So d square a d theta square, this would just be half square negative sine theta negative half sine half theta negative. So at theta equals to 2/3 pi, d square a d theta square should be a negative value, because just key in calculator, negative sine 2/3 pi negative half sine 2/3, so it's 1/3. So just key in calculator is negative, hence a maximum. Okay, there you go. Yeah, maximum area. Then you just be just replace it in, because a is this one, half r square. I'm going to sub into here, half r square sine 2/3 pi plus r square pi minus half theta. One-third pi. Yep. So sine 2/3 pi, that will be, if you've forgotten how to find this exact value, square it, root 3 over 2. It will be 3/4. That's the answer. I hope I don't have any careless mistake. The 3/4 r square root 3 square units. So this is how you do it. So if you're not very comfortable using Trigo, like I say, you can actually use the variable. Now r cannot be a variable because r, no matter what you take, is a fixed value. What you can let x be either this length here, but this length is not a very nice length to be variable, okay, because it's very hard. Okay, this hypotenuse here is very hard, I believe. So I would suggest either use this height here. Actually, this would do. This height is pretty good as well, or this x here. Okay, this x here is a better one. I think that would be the better variable then. Okay, so I'm going to use method 2, which is use algebra. Method 2. Okay, so this case here, same thing here, here, and here. Isosceles triangle, and there's a R. So I'm gonna be is it ABC as well? So ABC. Okay. Now same thing. We need to pick one side to be they call it. We need to pick one side to be variable. So this case here, I think is good to let this be variable. This for the perpendicular. This is x here. Okay, and these are all R. Is much better here. Okay, and then you realize that this is F lah, usual. Let F be foot of perpendicular of O to AC. So let AF equals to X. Okay, X units. Well, I think this algebra is much easier. So OF will be by Pythagoras theorem, like what some of you have suggested, which is to use Pythagoras theorem. You can. So this is square, right? That's pretty okay. Then area of triangle, it will be ABC, would then be half AC times BF. Okay, that is so fast. So this is half. AC is actually, this is also X, right? So this is 2X. There's 2X. And this BF would be R plus OF. OB plus OF. Okay, then this will just be X multiplied by OB, which is actually R plus R squared minus X squared. A, and A. Okay. Do you need to, okay, so what we're going to do here is I'm going to just take note, R is a constant. So when you differentiate this, so dA is dx, okay? So this will be, we're going to use product rule, half, so dA dx. Keep the one on the left, which is x. This is R plus half, R squared minus half, minus 2x plus R plus R squared 1. Okay, so key this in, and what we're gonna get is actually XR minus R squared minus X squared plus R. Okay, I'm gonna just calm down first here. You see, careless mistake. Differentiate R is 0. Because it's a constant. So this is 0. Minus 2x squared. My goodness. Let's multiply this in. Then keep the one on the right, division at the 1. Okay, great. So this is it. Just take note. I'm checking whether do I have any other careless mistake. I think there's no careless mistake. So as stationary value, dA dx is 0. So this will just be x squared just expand this. Try and I think this is a common denominator. Does it work? Yeah, it works. Okay. So you just make these two a common denominator. This will be, this R is very annoying. So this case here will be okay. Then this case here, wow. This is where we just rearrange square both sides, and then we will get this. And once we get this is square, factorize it out, 4x squared plus 3r squared. So this case here, get x squared equals to 0. So of course reject x has to be bigger than 0. That's for sure. There you go. Okay, this is it. Yeah. Then we're gonna use the area. If you show is maximum, right? We could actually use second derivative test. It's gonna be very annoying, so we're gonna use first derivative test. This would be, I think just use the first derivative test. Is easier for this case. So this is x, the variable, and this is root 3 over 2r. So this is dA dx. Then the slope is here. This is 0, so the slope here is just horizontal here. Then you put a root 3 over 2r plus root 3 over 2r minus. Plus, you can see that this is always positive, so it's not really an issue. What is an issue is actually, this is also always positive. What is an issue is actually this one here and this one here. Okay, so you just look at dA dx. Okay, so I'm going to rationalize the denominator here. Multiply top and bottom with the same stuff. Okay, you can actually key in calculator and check. So like this r, you put a small value of x slightly bigger, and key in and see whether you get positive or negative. But this is first derivative. I'm not gonna try and show it here. It looks complicated, but it's a maximum area, right? So this should be negative, positive here. Hey, sorry, this is positive, negative. This is negative, and this is positive. Okay, so once done, what we're gonna do is we're going to just maximum area. Put it in. R root square. Yeah. This is r square minus half. This is 3. Wow, okay. Here you go.